Lesson 1.10, Rounding Decimals. Rounding is a form of estimating. A lot of times we want to round to make math quicker, so we can do quick calculations, mental math. Sometimes we just need an approximate answer, so we round. In order to round, though, you need to know place value. So we look at this long number. The first 3 digits are the ones area. The next 3 are the thousands, millions, and billions. The decimal point is the word and. In the ones, we have ones, tens, and hundreds. In the thousands, we have thousands, 10,000s, 100,000s. Then we have millions, 10 millions, 100 millions, billions. Going the other direction, after our decimal point, we don't have an equivalent to the ones place. There's no such thing as a oneth, but we do have tenths, hundredths, thousandths, 10,000ths, and so on and so forth. The pattern on the second side matches the pattern on the first side, just in the opposite direction. In order to round a whole number, we look at the digit to the right of where the rounding is to occur. If that digit is 5 or greater, we round the digit to be rounded up by 1 and replace the remaining digits with 0. If the digit to the right is less than 5, we keep the digit to be rounded the same and we replace the remaining digits with 0. So for example, if we round the world population to the nearest million here, we look at the 5. 5 is 5 or greater, so it's going to round the 1 up to a 2, and all the digits past that became replaced with zeros. If we round to the nearest 1,000, that's this decimal place here, we look at this digit next to it to the right, which is a 1. That means we're going to keep this digit the same, a 3, and all the other digits are replaced with zeros. So let's try this. Let's round 6,751,593,103. You'll notice I did not say and in there. I would only say and if there was a decimal. So rounding to the nearest billion, I'm going to rewrite the number. Here's billion. So we look at the number to the right, which is a 7. 7 is greater than 5. So we're going to round the 6 up to a 7 and replace all of the other numbers with zeros. This symbol that I drew here, that means approximately equal to. We use that symbol when we've estimated. To the 100 millions, well, we have our ones, thousands, millions. Here's our 100 millions. We look at this digit, it's a 5, therefore the 7 will round up to an 8, and all other numbers get replaced with zeros. And finally, to the 10,000s. 10,000 is located here. We look at the number to the right, which is a 3, that's below 5. So the 9 will stay a 9. And all the other digits will be replaced by 0. Now let's see what would have happened if that 3 was replaced with a 6. That 9 will get rounded up to a 10, but I don't have room to fit a 10 in here. So not only does the 9 round up, so does the 5. So this goes up to 10, which means this goes up to 6. Rounding the decimal part of a number is the same as rounding a whole number. The difference though is instead of replacing all of the remaining digits with 0, we just leave them off because 3.1 and 3.10 or 3.1000 are all the same value. These zeros are unnecessary. So pi, the first 7 digits, is 3.141592. If I round to the nearest hundredth, these are tenths, hundredths. I look to the right, that's a 1. So pi rounds to 3.14. If I round to the nearest thousandth, so tenths, hundredths, thousandths, I look at the next number over, it's a 5. That's going to round the 1 up, so it would round to 3.142. If we round each of these to the nearest tenth, hundredths, and thousandth, our tenth is a 6, so we look at the 8, that'll round it up, so that rounds to the tenth. If we round to the hundredths, we have an 8 in the hundredths place, the 9 will round that up. And if we look at the thousandths, we have a 7 next to that, which will round that up. This 9 will get rounded up to a 10, so that 8 will become a 9. Our 3 keeps the 9 the same. Our 6 rounds up the 3. And our 2 keeps the 6 the same. Our 5 rounds up the 2. Our 3 keeps the 5 the same. And this 3 keeps the, and the 6 rounds up the 3.